cost benefit principle. So this principle states that a rational individual should take an action if the additional benefit from taking the action are larger than the additional cost. So I should ask the question that should I do the activity X? And yes, if the additional benefit is greater than the additional cost. And if the opposite is true, then the answer is no. I can also state this principle in a different way, that a rational individual should take an action if the economic surplus is greater than 0 or positive. Economic surplus is the difference between additional benefit and the additional cost. So if the economic surplus is positive, then I should do the activity X, and if it is not, then I should not do the activity X. Now let's consider an example. Let's say you want to consume ice cream and you are trying to decide how many scoops of ice cream you want to consume. So here the economic surplus is related to your happiness, refers to your happiness. So if you want to maximize your happiness, you basically want to maximize the economic surplus. So you want to find out the amount of scoops uh, you know you want to consume in order to get the maximum satisfaction or happiness. So the economic surplus of n units is equals to total benefit of n units minus total cost of n units. So in order to find the n which maximize the economic surplus, the easiest way is to find the economic surplus of every single quantity and then pick n which has the highest economic surplus. But that's the tedious process. So we can do a slightly different thing. We can ask the qualitative questions, that is yes no questions. For example, we can start from 0 scoop of ice cream and we can ask the question, should I have the first scoop of ice cream? And if the additional benefit is larger than the additional cost, then I should consume the first scoop. And similarly, I can ask the second, third questions, and so on. So I should consume the nth scoop of ice cream if additional benefit of the nth scoop is larger than the additional cost of nth scoop of ice cream. So here we are basically thinking at the margin. So marginal is a fancier way of saying additional. So marginal, they basically have the same meaning. So marginal benefit of nth unit is equals to total benefit of n units minus total benefit of n minus 1 units. Similarly, marginal cost of nth unit is equals to total cost of n units minus total cost of n minus 1 units. And if marginal benefit of nth unit is greater than the marginal cost of nth unit, then I should do the activity X, nth unit of activity X. Now the question arises, why do we stop at the nth unit? Why do we not consider the n plus 1th unit? So there are basically two assumptions in the background. Assumptions. The first assumption is marginal benefit is non-increasing in additional units. That is, it can either stay same or decrease. And this is a very reasonable assumption, because as we increase quantity, we start getting satisfied. For example, like when we start consuming more and more ice cream, we start getting satisfied, right? Second assumption is marginal cost is non-decreasing in additional unit. And this is also a very reasonable assumption. So because of these two assumptions, we stop at the nth unit. Now, so far we talked about the quantity which vary in integers. But what about the quantity, goods or activities which are perfectly divisible? Goods or activities perfectly divisible. What I mean by this is these quantities can vary continuously. For example, time, water. Like you could deny for a bottle of water, but it could be the case that you accept a cup of water, right? So these quantities vary continuously. So in this case, how do we find out the optimal quantity? So first, let's consider we do the the additional delta unit of activity X if total benefit Q plus delta units minus total benefit Q units is greater than the total cost of Q plus delta units minus total cost of Q units. Now when we divide, let's divide by delta on both sides. Divide by delta and let delta approach 0. So the left side gives us the derivative of total benefit, and the right side gives us the derivative of total cost. So this is nothing but marginal benefit, and this is marginal cost. So when we equate marginal benefit with marginal cost, it gives us the optimal quantity. Now let's do the allocation of resources. resources. Let's consider an example which will help us to make our concept very much clear about the marginal. So let's say you want to collect gold, and you have 4 gatherers: first, second, third, and fourth. You can send these gatherers either to the east or to the west. Now these two columns basically gives us the average output per gatherer. Now let me cook up some numbers. So this is 10, 10, 10, 10. This is 13. This is 12, 11, and 10. So now looking at these numbers, we can say that the average output per gatherer in west is higher than the east. So we may feel that we should send all 4 gatherers to the west, and if we do so, then the total output that we get is total output is equals to 4 times 10, right? When we send 4 gatherers, the average output is 10, so the total output becomes 4 times 10. That's 40. Now let's do it from marginal. Let's first calculate the marginal, and then we'll calculate the total output, and then we'll compare the values. So in order to calculate the marginal, we'll first calculate the total. So here total becomes 10. Here 10 times 2 is 20, 30, and 40. And here 13, 24, 33, and 40. Now we'll basically take the difference between the totals, and we'll get the marginal. So here for the 0th gatherers, the difference is basically 10, for the first gatherer, and to calculate the marginal of the second gatherer, we'll basically take the difference between first and second. That's again 10, 30 minus 10, which is again 10, 30 minus 20, and then this is also 10. And similarly we'll calculate the marginal for the west as well. So this is 13, and this is 24 minus 13, which is 11. This is 33 minus 24, which is 9. 40 minus 33, which is 7. Now looking at the marginals, we can clearly say that we should send the first gatherer to the west, because the marginal 13 is greater than 10. Similarly, we should again send the second gatherer to the west, because again this 11 is greater than 10. And for third gatherer, we should send him to the east, because 10 is greater than 9. And we should send fourth to the east, because 10 is greater than 7. So in order to get the maximum output, we should send 2 gatherers to the west and 2 to the east. So when we do so, what is the total output? So total output is equals to 2 times, when we send 2 to the west, the average output is 12, right? And 2 to the east, so the total output is 10. That gives us 24 plus 20, which is 44, which is definitely higher than 40 that we get at, that was the value we obtained previously. So this is the optimal allocation of resources. Now let's learn about opportunity cost. Opportunity cost of a choice. Now, what is opportunity cost? So, opportunity cost is basically the same as the value of the opportunities lost. Opportunities lost. We can also define this as the value of the next best value of the next best alternative that must be foregone. That must be foregone to undertake the activity. The opportunity cost includes two types of cost: monetary cost, which is also the explicit cost. Second, non-monetary cost, which is also the implicit cost. Now let's do the example. Let's say you spend $100 on meals every day. That's your daily expense on meals. Now there is an opportunity for you to pick up the check of $450 at Disneyland, and the ticket to Disneyland costs you $400. So now the question is, should you pick up the check? That's the question. So here the $100 is irrelevant in our analysis because that's the fixed cost. That's that's the amount we spend every day on meals. That does not impact our decision, you know. So let's now take these two numbers, $450 and $400, into our consideration. So since the ticket cost is lower than the the reward that we'll get once you enter the Disneyland, so we should go and pick up the check, right? So the answer is yes, we should go and pick up the check. And one important thing that we noticed that we should not include the fixed cost in our cost and benefit analysis. Now let's make some changes in this example. um, let's say we again spend $100 on meals every day, and there is an opportunity to pick up a check of, let's say this time, $300. Pick up a check of $300 at Disneyland, and the ticket to Disneyland costs you $400. Now this time you happen to own a non-refundable ticket. So now the question is, should you pick up the check? So again, this $100 is irrelevant because this is fixed cost. Now the ticket cost is also irrelevant in this question because it says the ticket is non-refundable. So this is a kind of sunk cost. So sunk cost is a type of cost which cannot be recovered, so since the ticket is non-refundable, this ticket cost cannot be recovered, so we'll not take this into our analysis. So now whether now since you'll get $300 as a reward once you go into Disneyland, So you should go and pick up the check, right? So the answer is yes, you should go and pick up the check. Now let's make some more changes in this example. Now let's say this time the ticket is refundable, and $100 on meals every day, uh, the check of $300 at Disneyland, and the ticket is also $400 as previously. The only change is the refundable ticket. Now should you go and pick up the check? So again, $100 is irrelevant, but now this time we need to consider the ticket cost, $400, because the ticket is refundable, which means this ticket is cash equivalent, which can convert this ticket into cash. So since the reward, that is the value of the check, is smaller than the ticket price, we should not go and pick up the check. So the answer is no, we should not go. And okay, so that's it for this video. Thank you for watching.